Good morning, students. Hope you're having a lovely snow day today. Making a quick tutorial here for you guys so you can learn how to graph with the table of values before we come back for our quiz on Friday. So, let's get right into it. So let's say that we have a problem where I am thinking of two numbers, and those two numbers add up to 10. So, if I'm thinking of two numbers and they add up to 10, what two numbers would those be? Think about that for a second. Okay, you've thought about it. If we ask everyone in the class what two numbers I'm thinking of, what might people say? Are we all going to say the same thing? No, Mr. President, we're not. Why is that? Because there are different ways that we could do it. Good job, class. I'm so glad you came today. So, someone might say that it might be 5 and 5. Or someone else might say it might be 1 and 9, or 2 and 8. So how many possibilities are there? Well, we've already listed 3. Is 1 and 9 the same thing as 9 and 1? Or are those two different possibilities? What's that? You think they're two different possibilities? You guys are so smart. So we might say that we have all of the numbers from 1 through 9 and their counterpart can add up to 10. What about 0? Could we do 0? Yeah, we could do 0. We could do 0 and 10, and the reverse of that, 10 and 0. So we can see we're starting to get quite a few. But I think we could list them all. Wait, what about decimals? Could we do decimals? Could I do 9.9 and 0.9? Could I do 1.2 and 8.8? Okay, so that means we've got a lot more decimals to be writing in there. Could I also do 9.999 and 0.001? Yes, we could. Okay, so now we've got all the decimals that we need to take care of. What about negatives? Could I do -8 and +18? That would work too. So, question, is there any number that I can't use for the first number? Can you think of any number that doesn't have a number that goes with it? What about 1,000,000? What about 1,000,000, Mr. Pasimio? Okay, let's put 1,000,000 right there. 6 zeros. Okay, so if I had 1,000,000 for the first number, could I figure out what second number goes with it? Yes, we could. So if I had 1,000,000, I would need to have a negative number that goes with it. So that negative number would be negative 999,990. Okay, so I could pick any number that I want for the first number and come up with a second number to go with it. So how many different combinations of numbers can I come up with where the number adds up to 10? The answer is infinite. So, you're thinking, okay, this has infinite answers, we're done. No, I need you to tell me all infinity answers. So how are we going to do that? So, a solution to this was come up with by the French mathematician René Descartes. So, right here at the very beginning, I see that one of the solutions is if the first number's 5, the second number's 5. So how do I express that? Well, René Descartes made a number line like that. And he said that number line is going to represent the first number, but now I need a second number line to represent the second number. So we're going to make another one vertically. And eventually we started knowing that the first number was called the x and the second number was called the y. So if I wanted to express that one answer, when the first number is 5, 5 along the x-axis. The second number is 5 along the y-axis. And we would put a dot right there to represent that this is 5, 5, expressed as an ordered pair, which we've already worked with. Let's do the second one. The second one was when the first number is 1, the second number is 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 1, 9. And then 2, 8. And then, let's go backwards. Let's do this one, 0, 10. And hopefully what we should be noticing is that these solutions follow a specific pattern. Now, what I have right here is I have 4 solutions, but as we've established, this question has an infinite number of solutions. So what I can do here is I can notice that these solutions are following a pattern, and after I've seen 4 dots, I can see that the pattern is going to follow a straight line. So what I can do is I can draw a straight line which represents an infinite number of dots. And every single solution to this question, what 2 numbers add up to 10, is going to land on this dot. So for example, 0 and positive 10. So if the first number is 0, oh, I accidentally already graphed that one. The one that I meant to graph was over here, where the first number is 10 and the second number is 0. So that is the way that I can show all infinity solutions to the questions, what 2 numbers add up to 10. So let's talk about what types of problems you'll be seeing on your homework today. So I want you to tell me all of the solutions to the equation y is equal to 3 times x minus 4. So what this means is I'm thinking of 2 numbers, and if you take the first number times 3 and then subtract 4, you get the second number. So I'm going to make a table of values here. So what the table of values is I'm going to say what the x is, what the y is, and then I'm going to give myself a little bit of room to work in the middle. I'm going to write down the equation right here, 3x minus 4. So the neat trick here is that since I know there are an infinite amount of solutions, I can pick whatever number I want for the input. So, the easiest number that we usually start with is 0, because anything times 0 is 0. This is nice and easy to work with. So if x is 0, I'm just going to plug this in. Y equals 3 times 0 minus 4. So 3 times 0 is 0, minus 4 is negative 4. So, when x is 0, y is negative 4. This gives us the ordered pair 0, negative 4. Now, let's graph that. I don't want to draw another graph, so if you just right-click on your screen and then push paste, a graph should appear. Let's move that out of the way a little bit. Oh no, what have I done? Okay, excuse me a moment. Let me adjust this. Negative 4, 0, negative 4. Okay, so 0, negative 4 would go right here. Okay, now, with that one solution, I can't see exactly where the line is going to go. It could go straight up, it could go straight horizontal. So I need an additional point to figure out where the line's going to go. What would the next easiest number to plug in be after 0? 1, Mr. Pasimio. Good job. Let's plug in 1. So if I plug in 1, I'm going to get y equals 3 times 1 minus 4. 3 times 1 is 3. 3 minus 4 is negative 1. So that means when x is 1, y is negative 1. Giving me the ordered pair 1, negative 1. 1, negative 1. So at this point I can see that I've got two solutions, and I could draw a straight line going straight through them, representing all infinity answers. What I want to do is I want to do one more point just to confirm that the answer is correct. Because if I draw two dots, I can draw a straight line through them, even if one of them is wrong. But if I draw 3 dots and they all line up, then I know I've done it right. So let's go ahead and enter in the next number, 2. Y equals 3 times 2 minus 4. 3 times 2 is 6, minus 4 is 2. So that gives us this point, 2, 2. So 2 along the x-axis and 2 along the y-axis gives us that. Now I can see that my 3 solutions that I've come up with line up perfectly. So 3 solutions on my graph, but I need to show all infinity solutions. So I'm going to start connecting these dots, and I'm going to put arrows on them to show that there are an infinite number of solutions, all of the solutions landing on this line. Let's do one more. Let's do y is equal to negative 2x plus 5. Go ahead and paste the graph in there ahead of time. That way I don't mess up my table later. Oops, I've gone too far. There we go. Okay, again, creating the table of values, x, y, negative 2x plus 5. Remember, you're allowed to pick whatever number you like for x. So here's 0, negative 2, y equals negative 2 times 0 plus 5. So negative 2 times 0 is 0, plus 5 is 5. So 0, 1, 2, 3, 4, 5. 1, y equals negative 2 times 1 plus 5. Negative 2 times 1 is negative 2, plus 5 is 3. So I've got the point 1, 3. 2 would be y equals negative 2 times 2 plus 5. That'd be negative 4 plus 5, which would be 1. So positive 2, positive 1. I've got my 3 solutions out of infinity, so I'm going to connect them. All infinity solutions are going to land on that line. There's the solution, and I'm done. So, now that we've learned this, go ahead and download the worksheet from the class resources page. Don't forget to do your post-class reflection, because there's totally a post-class reflection today. Thank you for watching, and enjoy your snow day. Stay safe and warm.